So, good morning everyone. Our topic for today is all about the more discrete probability distribution. And now we are going to discuss the geometric distribution. Okay, so geometric distribution is a discrete probability distribution and it should satisfy the four conditions. First, a trial is repeated until a success occurs. Second, the repeated trials are independent of each other. Third, the probability of success is constant for each trial. And the last, the random variable x represents the number of the trial in which the first success occurs. So the probability that the first success will occur on trial is, so this is the formula, p of x is equal to p of q raised to the power of x minus 1, where q where where q is equal to 1 minus p. Okay, so example using the geometric distribution. A study found that the smartphones made by a certain manufacturer had a failure rate of 43%. Four smartphones made by this manufacturer are selected at random. Find the probability that the fourth smartphone is the first one to have a failure. So, this is the solution using the geometric distribution. Okay, so using, we have here given p is equal to 0.43, q is 0.57, and our x is equal to 4. Okay, so now we substitute the given here to the formula given. So p x, which is 4, is equal to 0.43 times the q, which is 0.57 raised to the power of 4 minus 1. So 0.43, 0.57. So 4 minus 1, 0.43 times 0.57 raised to the power of 3 is 0.080. So this is our answer. So the probability that the fourth smartphone is the first one to have a failure is about 0.080. Okay na? Oh, sorry. So Poisson distribution. It is a discrete probability distribution. It should satisfy the three conditions, which is the experiment consists of counting the number of times an event occurs in a given interval. The interval can be an interval of time, area, or volume. Second, the probability of the event occurring is the same for each interval. Third, the number of occurrences in one interval is independent of the number of occurrences in another intervals. So, but these conditions has an continued but these conditions has there is one added to these conditions. The fourth is the probability of exactly x occurrences in an interval is, we have the formula f of x is equal to mean raised to the power of x where e or Euler's number is approximately equal to 2 point and this one is we call mean. Example using the Poisson distribution. The mean number of accidents per month at a certain intersection is 3. What is the probability that in any given month 4 accidents will occur at this intersection? So the solution is, well, we have in the given, we have the s is equal to 4 and the mean is equal to 3. So we have 4 the mean, which is 3 raised to the power of 4, and the e or Euler's number is 2.71818 raised to the power of the minus mean, which is 3. Listen. 4 factorial is approximately equal to 0.168. So this answer. Example of finding a Poisson probability using a table. A population count shows that the average number of rabbits per Example of finding a Poisson probability using a table. A population count shows that the average number of rabbits per acre. Example of finding a Poisson probability using a table. A population count shows that the average number of rabbits per acre living in a field is 3.6. Use a table to find the probability that 7 rabbits are found on any given acre of the field. So here is a table for Appendix B. So using the distributor for So this is the table for Appendix B. So using the distribution for mean, which is 3.6, and x, which is 7. So this is the table for Appendix B. Using the distribution for mean, which is 3.6, and the x, which is 7. So we can see the Poisson probability, which is 0.0425. Since my blackboard is small, so I'll directly put the Poisson distribution if the mean is 3.6 and the x is 7, and it is 0.0425. So according to the table, the probability is 0.0425. We can check this result using technology, which is the Excel, and the probability is 0.0424. So according to the table, the probability is 0.0425. So we can check it using a technology, which is the Excel, which is the probability is 0.042484. And after rounding to 4 decimal places, the probability is 0.0425, which is the same value found using the table. That's all. Thank you.